folks, I welcome you back to Global Education Zone, and in this episode I'm going to be dealing with this question in which we have a right cone parallel to the principal plane, and this cone here, we want to turn the cone so that the side AB, so you can see this is side AB, this side AB is resting on the horizontal plane, and you draw the front elevation and end elevation and the plan. So we need to draw the front elevation, end elevation and the plan. So I will begin to answer the question now. So the first thing I'll do now, I will draw the side of this shape. So for the side we have I'll draw the length on the side. So here we go. This is the actually the key view here is the front elevation because we are turning the side AB. So let's say this length of side AB is something like 1, 2, 3, 4, like a 4 centimeter side. So AB is 4 centimeters. That's actually the height, 4 centimeters. So I've taken it. Then we have the remaining as 4 centimeters, 4 centimeters, and 3 centimeters. So now just need another side, 4 centimeters. So I open my compass to 4 to 34. So next I'll cut an arc. This is this arc. Then I'll need a side of 3 centimeters. So embody the arc. So there we go. Okay, I guess this is. So let's assume we could use a side of 2.6 centimeters. 2.6 centimeters. 2.6 centimeters. There we go. So when I join the three sides, I will have my shape. So actually I'll use this pencil. Join the three sides to get my shape. Then next I have to draw the plan. So basically I'll just be drawing vertical lines from each of these sides. But first of all, I want to divide this side BC into a number of equal parts. So this BC, these are A, this is B, this is B rather, this is C. So this height has been drawn now. So this side is resting on the horizontal plane. So basically now let's move on. So actually this should be AB. This should be AB. Because AB is now resting on the horizontal plane. Then we have C. So this is the correction I've made. I've made a correction there. This is AB. So the next thing to do is I will divide this side. I'll construct a semicircle on this side and divide it into a number of parts. So now the first thing, I'll just need to bisect this line. I could just, since it's 2.6, I can just take the midpoint as 1.3 by dividing it into 2. So it's not every time you need to be dividing your lines. You can just use your ruler instead. Then I will construct the semicircle. So here we go. This is yes. Okay, it's cool. So this is semicircle here. And then the next step is you divide the BC into a number of into an even number of equal parts and project lines horizontally to the end elevation. So vertically to the plan and perpendicular to BC to the semicircle. So that's exactly what I'll do. I'll divide into a number of equal parts. Let's say I'm divide this into 2 equal parts. So if this 13, this will be 6.5. Then yes. Then I also have this to be. So this should be the midpoint here. So now these equal parts, I will project lines from these equal parts to the plan. So I don't know how my plan looks yet, but I'll need a vertical line. So this vertical line, I will draw lines parallel to the vertical line for the remaining plan lines. So here we go. So I have the first division, second division, and third division, and last division. So then I need to move on with all this. So I've transferred them to the plan. I also need to transfer them to the front elevation. So that's what I'll do. Alright. So here we go. To the end elevation rather. This is to the end elevation. I'm projecting them horizontally to the end elevation. And then we're also going to project them perpendicular to the surface. That's to meet the semicircle. So I'll project these points perpendicular to the surface to meet the semicircles. Yeah. So this will be the first point. Yeah, perpendicular, second perpendicular, third perpendicular. And the next step is that we are going to take the distance from BC to the semicircle. But first of all, let's draw the plan. So this plan, it has a width. Actually, this width is basically the same width as the height on the front elevation, because when you turn this, you have the plan. It's still the same cone. It's as wide as this. Then this is when it is seen from above. So the cone has been toppled over. So it is still the same as this side. So we're going to pick a point. Pick a point from here. So it's that circle wide. I would transfer it to these points. So since they are equal, I can just transfer them. Or basically I can just, yes, I will transfer them. Each of these distances. So the 1, the 2, the 3, the 4. So then I need to basically kind of transfer these ones. So I need to draw a line parallel to these ones to the right. So here we go. This is the procedure. Doing that 1, 2, 3, 4. Last one. Then next we have so now I've transferred the divisions on that to here. But next we also need to transfer the divisions from the elevation to the plan. So I don't need this division, I just need the distance. So that distance is what I'll use for the curve. So that curve is the curve of the surface. So I don't know the curve of the surface yet, but I know that this is the extension, and it goes from the first to 1, 2, 3, 4 to the last. So it extends from here to here. So all I need to do first, I will then transfer the divisions to these points. So starting from here, we have the distance from this to the semicircle. So I'll take the distance from BC to the semicircle from 1 to 130 and mark them each side of a center line 0. Distance each side of a center line. So assuming this is my center line, I'll mark the distance from the center line. So it can't be greater though. So I'll solve this one. This should be smaller than this. So we have this first one here. So since there is a semicircle, because of symmetry, I also mark the same distance bottom. Then for the next one, so I can now transfer this to the right. So this will be the distance that will constitute my curve. So all I need to do, I'll just locate the point. So we have this point, this is the lowest point. So it corresponds to the center. When we take it down, this is the lowest point. So I guess, yes, this is it. Also that's the center. Then we have the edges too. So your curve always touch the edges. Then we have the middle. So we have this as the middle. This as the middle. So because this is from here and here, so that's why we have this as the middle. So basically, okay, this edge, we have this as the middle instead. So I have this here. That's the middle from here to here. So here. Then from here to here. So when we trace the line through the curve, we'll have something like this. So it goes like this. It goes like this. Then when I draw the curve, I'll use my hand instead of the French curve, because I'll need to save time, and because this curve is quite small, so I can't use a French curve. So although you can try using the French curve as a challenge, but then now I've joined this to the apex, so this is still the apex A. Now that's the plan. So now we've collected the distance, right? So now for the end elevation, you can just pick a vertical line from which we start. So start from here. So then we'll just take the top of the from here it intersect the vertical line. Then from there we'll draw a 45-degree line. So this 45-degree line will we'll use it to project the lines from the plan upwards vertically. So I'm projecting the first one upwards. Then we have this. Every single line that you see from the plan, you can project it upwards. So this is the center line. I can use center lines for this to differentiate it. Then I also have the next one. So then the last one. You can see we only have 5 lines to contend with. Now, next thing is we transfer the intersections. Now this middle point intersects the middle point here. So actually this middle point here intersects the middle point. This is the same thing as the middle point here. So it intersects at the edges. So the reason is that there's a perpendicular shifting of the plane. So for this, what is the center on the front elevation has now turned to the edge. So this edge will now intersect the center again at the end elevation. Then for this one, when we project this one down, that's for the edges. For this one now, it's at the center, and this one is also at the center. So that means this center will intersect the edges. So that's at the topmost right here, and bottommost. So you can see that little by little you can see the shape. This is a circular shape. When we lastly take this one, this will intersect from here to intersect this one here. So I got the point. Then we also have this one. Then also have this one and this one. So this one. So at the end of the day, you have this elliptical curve. So if I trace my pencil around it, I will get this shape. It looks like an ellipse. This ellipse is so this one is big enough for me to use a French curve for. So I can just slowly use a French curve for this. So I'll draw it in bits. So you have to draw it little by little so as to get the correct curve. Okay. So when I'm done with this, I can now trace the remaining ones with my hand. Those ones won't be so curvy. So like this one here, it's possible to trace lining with your hand. Although I don't advise you mix up French curve and hand. If you're going to use your hand, use your hand. If you're going to use French curve, use the French curve. But because of time, we'll do that. So then we have this curve, and this curve is the curve of the end elevation. So this is the front elevation, this is the plan, and this is the end elevation of this shape. Thanks for watching.